I hope each one of you can choose one to show, present at a presenting rate.
So for 11, I had to find the missing coordinate for x. And then since this is on the unit circle, I used the equation x squared plus y squared equals 1. And I plugged in 1 over 3 for y. And then it was giving me the information that this will be on quadrant 2. So I just wrote it down here. And then I solved for, not solved, I distributed 2, the exponent 2 for 1 and 3 and ended up with 1 over 9. And I wanted to have x squared on one side, so I minused 1 over 9 on both sides. So it's going to be x squared equals 1 minus 1 over 9. And then I put 9 over 9 for 1 because it's a whole number. So 9 minus 1 is 8 over 9. I rewrote the equation, so it's x squared equals 8 over 9. And then since it's a squared, I squared both sides and ended up with splitting the radical. So it's square root of 4 times 2 gives me 8. So I have the square root of 4 is 2. And for radical 2 it stays. So it's 2 square root of 2 over 3. It's plus and minus, but I forgot to write plus and minus. And then since it's in quadrant 2, the x has to be negative, so it's negative 2 radical 2 over 3.
Okay, great. Yeah, when we square root something, we always get two values, positive and negative two values. Yeah, with quadrant 2, you get this negative x value. With quadrant 1, you get the positive 2 radical 2 over 3. I wonder. Yeah. Okay, thank you, Rena.
Thank you.
Jeremy wants to show 1A, B, C. Great. Yeah.
I'm a presenter, right?
Oh, have I? Yeah.
Okay.
Yeah, I have made you presenter.
Okay.
Hopefully everybody can show something to show, to get your presentation.
Oh, you can see it, right?
Yeah.
Okay. So it was pretty simple. I just had to like fill in the blanks for A, B, and C. And it says the unit circle is the circle centered at the origin with radius. The blank was to fill this part, and I put origin. And then for B, it says the equation of the unit circle is, and then I put x squared plus y squared equals to 1. And then for C, I had to put in the missing x or y value of P, and it was 10.01, point negative 10, and 0.0 and negative 1. And that's 1.
Okay. Those 4 are the special points. Right. Okay, good. Thank you.
Thank you. Sure.
Okay, anybody else like to show, to present? All right, if not, we're going to keep talking about, we're in trigonometry, right? So this chapter is all about trigonometry functions, sine, cosine, tangent, so on and so forth. But before we do that, we try to understand 2 very important things related to trigonometry functions. One is a unit circle, and another one are triangles. Triangles called trig, right? Trig, T-R-I, means basically dealing with triangles. So how do we, right? So we can measure angles, right? How do we measure angles? We start from positive side of x-axis. Then we go counterclockwise for positive angle measure. negative, if we go clockwise, that's negative angle measure. Right? We start from positive side of the x-axis. We go counterclockwise, so we measure the angle. From this point up to this point, that would be pi over 2, right? 90 degree. We keep going, we go on a straight line, that's 180 degree, or pi. We keep going here, the downward y-axis, we run 270 degree, or 3 pi over 2. We keep going back to the point we started with. So we run 360, we run the circle, 360 degree, or 2 pi radian. So that's a unit circle, right? So that makes a circle. Well, we restricted this radius with 1, so we have a unit circle. So we're thinking about points, running around on this unit circle. Now, how do we look at those points? Let's see a point in the first quadrant. Point in the first quadrant, we can think about the point is a point on the unit circle, right? Let's talk about this point. This point is on the unit circle. It's also one of the vertex for this triangle. So how do we make this triangle? We connect this point with the origin. We call this line coterminal line. Then we drop a perpendicular line from the point to x-axis. So then with this part of this x-axis, we see this triangle. And what's the angle we talk about? We like to talk about this angle. So in the first quadrant, right? And imagine when we measure angle, we can keep going around, right? We can keep going around. We're running 1 round, 360, running 2 rounds, 720, running 3 rounds, that's 6 pi. Another 1 round, 8 pi, 10 pi, 12 pi, goes on forever, right? So how do we speak for those angles bigger than 2 pi? If it's bigger than 2 pi, it means we run more than 1 circle. So let's talk about this point, right? We run from the starting point up to here. Let's see, this is pi over 4, right? Pi over 4. We can keep running, right? So then that would be pi over 4 plus 2 pi. Or we keep running. That's pi over 4 plus 4 pi, so on and so forth. So we want to use a reference number. Or a lot of times we call reference angle because it is an angle measure. We want to use a reference number or reference angle to speak for those angles bigger than 2 pi. Bigger than 2 pi. We call it reference number. So this pi over 4 will speak for pi over 4 plus 2 pi, or speak for pi over 4 plus 4 pi, so on and so forth. So the smallest positive angle, all right? So in the first quadrant, we see this angle. This angle within this triangle. In the second quadrant, we do the same thing. We connect this point with the origin. We call this coterminal line. We drop a perpendicular line to the x-axis. So we have this triangle to talk about. So we measure angle from positive side of the x-axis, right? Running up to here, we see this angle is bigger than 90, but smaller than 180. Or smaller than pi, bigger than pi over 2. So we want to use an angle in the triangle to speak for this. We call it reference angle. So reference angle for this would be this angle, which is pi minus t. In the first quadrant, just t itself, whatever the angle it is. In the second quadrant, we use pi minus this angle. So that would be this angle. This is a supplementary angle. Similarly, in third quadrant, if we point on the third quadrant, we do the same thing. We connect the point with the origin, coterminal line. We drop a perpendicular line to the x-axis, so we have this triangle to talk about. Then the reference angle would be this angle. The reference angle of this angle would be this angle in the triangle. will be this one. The one formed in the origin, around the origin. So how do I get this angle? We use the angle, this angle, subtract pi. Subtract pi, so get this angle. Right? So that's when the point falls on the third quadrant. When the point falls on the fourth quadrant, we use 2 pi minus the angle. So see this, the point is here. We connect it with the origin, coterminal line. We drop a perpendicular line to the x-axis. We see this triangle. And the reference angle is this one. It's the angle about the origin. And that angle measurement is 2 pi minus this angle. So we see a unit circle, then we see 4 triangles. All right. So we would work. So trigonometry, we will work with a unit circle. We work with 4 kinds of triangles. So the triangles fall in 4 quadrants. So yesterday we talked about how to find reference number, right? We just follow this. If it's in the first quadrant, just the angle itself. Second quadrant, we do pi minus the angle. If the point on the third quadrant, we do the angle minus pi. If the point on the fourth quadrant, we do 2 pi minus the angle. Okay, we follow this formula. Okay, so I give you some homework last time, and I'm going to give you more homework. So that's homework 14. So homework 15. Let's try to find some reference angles. So let's see here. Okay, let's do 35 up to 38. Find reference angles. Okay, let me see. Find the terminal points. Did I talk about find the terminal points? Or maybe not. It's okay. Let's not find the terminal points. We will find the terminal points later. All right. We will use a special relationship. So let's just find the reference number or reference angle. Okay. By using these 4 formulas. You figure out if the point in the first quadrant, if it's in the first quadrant, it's just the angle itself. In the second quadrant, do pi minus the angle. If in the third quadrant, do the angle minus pi. If it's in the fourth quadrant, do 2 pi minus the angle. All right. So let's use this 4 to do the homework. 35 up to 38. So 35 up to 38. So this is part of it. Homework 15. Draw the picture, right? Draw this. Then try to figure out, let's see, 5 pi over 4. So we know the angle, right? We measure the angle, positive angle. We go from here. And the 5 pi over 4 is pi plus pi over 4, right? So this is a pi. We run straight lines, that's pi. Well, then plus pi over 4, so end somewhere here. Then you see a triangle here, right? You form a triangle here. Okay, so today we're going to start talking about trigonometry functions. If anyone has any question, feel free to stop me, all right? Ask me questions. Let me try to find a rectangle. Okay, let me draw one myself. Let's see, we have right triangle. I'm trying to form a right triangle. Right, I have this right triangle. So this is a right angle here. Right angle here. Well, let's call some names. Let's call this, let's call hypotenuse C. Let's maybe call this base B. Let's call this maybe like a height, altitude. Let's call it A. So I have these three sides, A, B, C, right? So let's see, I could talk about this angle, right? Let's talk about this angle. Let's call this angle D. Well, I could talk about this angle too, right? But for now, let's talk about this angle. Oh, you know what? Let's use T because the book so far we're using T for the angle measure. So T. So triangle is a constrained object. So that means the sides and the angles have very close relationship. So I could talk about the ratio. I could talk about the ratio of A over, or let's say B over C. Right? You know, what is the ratio of side A? So this is the side I call A. So length of this I call A. Length of this I call C. Length of this I call B. And now I call this angle T. Call this angle T, right? So I can talk about the ratio. You know, what is the ratio of B over C, right? B over C. And I give a name. It's a definition. I call it sine T. The ratio B over C, think about B as a number, C as a number, right? B over C, it's just a ratio, just a fraction. And I give a name, I call this sine T because triangle, the angles and sides are very closely related. So I just call this ratio B over C sine T. What some people know is the opposite over hypotenuse, right? The side opposite to 90 degree, we call hypotenuse, right? So opposite B is opposite to the angle T. So some people call opposite over hypotenuse, and that's sine T. Well, I can talk about A over C, right? What is the ratio of A over C? We call it cosine T. You know, what is sine T? What's sine T? Sine T is just a ratio. This is B over C, opposite side of T over hypotenuse C. What is cosine T? Cosine T, we call this A adjacent to this angle T. We say that it's the ratio of adjacent side over the hypotenuse, or A over C. That's cosine this angle, right? Or we could think about, you know, I can talk about this angle. Well, let's call this angle, maybe let's call it S. Right? Let's call this angle S. I can also talk about angle S, right? So let's figure out what's sine S, what's cosine S. Sine S, according to the definition, opposite side, the side opposite to S over hypotenuse. So that equals to A over C. Similarly, let's think about cosine S. According to the definition, cosine S is the adjacent side, adjacent to S, to the angle S, over hypotenuse, which is B over C. Well, let's check. Let's see. Here I have A over C equals to cosine T. Here I have sine S also equals to A over C. Yeah, we see this relation. We see these two equal to each other, right? We see these two equal to each other. And also we see these two equal to each other. We see sine t equals to cosine s, because both of them are equal to b over c. Right? So we call those co-functions. What's s plus t? And also let's check out s plus t, those two angles. Equals 90 degrees, right? Or pi over 2. Equals pi over 2, or 90 degrees. And when two angles adds up to 90 degrees, we call them complementary angles. Complementary angles. So sine s and cosine t are called co-functions. Sine t and cosine s are called co-functions. All right. So that's why, we need to only focus on one angle. Once we know what happens with this angle, we will know what happens with the other angle. Because the third angle is 90 degrees. And s plus t equals 90 degrees. Those two are complementary angles. And sine and cosine makes co-functions. So in the end, trigonometry functions, as long as we know sine function, we know the rest of trigonometry functions because they are closely related. All right, so that's the definition of sine and cosine. And then, well, let's talk about one more, tangent. Tangent, let's talk about tangent t. Tangent is defined as the opposite side of t over adjacent side of t. Well, what's the opposite? Let's look at the t. Which side is opposite to it? B. Which side adjacent to it? A. So equals to b over a. Well, let's talk about tangent s. You see that's a over b, right? If we look at the tangent angle s, tangent s, opposite side is a, adjacent side is b. Right? Okay, also we can rewrite this tangent t. Well, let's think about what's sine t divided by cosine t. Sine t divided by cosine t. Well, sine t is b over c. Then divided by cosine t is a over c. How do we divide the two fractions? We keep the first fraction, then we change the division into multiplication. We flip the denominator, a over c, right? We take its reciprocal, which is c over a. Now, when we multiply two fractions, we multiply numerator with the numerator, b times c. We multiply denominator with the denominator. So denominator will have c8. Oh, see, numerator will have c, denominator will have c. So c divided by c equals 1. So we're left with b over 8. Well, what is b over 8? B over a is tangent t. Equals to tangent t. Okay. So that's why we have tangent of the angle equals to sine of the angle divided by cosine of the angle. All right, so tangent equals sine over cosine. We have this relationship also. All right, now let's see here. So definition of trigonometry functions. Let t be any real number. T, remember, represents the angle. All right, t represents the angle. So let's see, in this picture, t represents running this point running around the unit circle up to here. Right. So what is the angle? The angle is from here to here. That's the angle. Right? That's the angle measure from here up to here. So let's see, because it's on the unit circle, right? Unit circle, for any triangle we draw, the hypotenuse is 1. Let's draw this triangle. Let's look at this triangle. You see the hypotenuse is 1, right? Because the hypotenuse is this one. The hypotenuse is the radius of the circle. So that's exactly why we want to use unit circle, because the hypotenuse is 1. So we would have a y value. We're talking about this. The reference angle is this one, right? Is this angle inside the triangle. For this one, it happens the point ends at the second quadrant. So we would look at this triangle. The reference angle of this angle is this angle inside the triangle. So we can say sine t equals the opposite. Well, what's the opposite? Opposite is the y value of this point. Y value of this point divided by hypotenuse. Hypotenuse is 1. The radius of this unit circle, which is 1. So that's why here we have sine t equals to y. Similarly, we have cosine t equals to x, because x divided by 1. And tangent t equals to sine t over cosine t, y divided by x. Where we want to restrict x not to be 0. Where we cannot divide something by 0. And similarly, we have other 3 trig functions. One is called cosecant. Cosecant is 1 over sine. All right. Cosecant is 1 over sine. You see, sine is y, sine t is y, and cosecant t is 1 over y, which is flip. The cosecant equals to 1 over sine. And secant equals to 1 over cosine, 1 over x. And cotangent equals to 1 over tangent. You see, it's just flip of tangent. So we have these 6 trig functions. Sine, cosine, tangent. Sine equals to opposite side of t, of the angle t, divided by hypotenuse. Cosine t equals to adjacent side of t over hypotenuse. Tangent equals to opposite side of t over adjacent side of t. Or sine over cosine. Secant, cosecant equals to 1 over sine. Secant equals to 1 over cosine. Cotangent equals to 1 over tangent. Right? Reciprocal. So 6 functions. Let's see example 1. Evaluating trigonometry functions. Find the 6 trig functions of each given real number t. Right? So this angle is given as pi over 3. Well, let's look at the triangle, right? Let's think about the triangle. To have this right triangle. Right? This here is 90 degrees. Because I dropped a perpendicular line to here, right? That's a 90 degree. So we have a given a point, we make a triangle here. So this point is in the first quadrant. So make a triangle in the first quadrant. Then this is the angle t, right? So this curve, this part measures this angle. This angle inside this triangle. So this t equals pi over 3 is this angle. X-axis formed with this coterminal line. So this angle is t equals pi over 3. Well, So let's use the definition. So sine pi over 3 equals to, so this point is given x value is half, y value is root 3 over 2. So sine of this pi over 3 angle equals the opposite over hypotenuse. Well, hypotenuse is 1 because we fix this on the unit circle. So hypotenuse is 1. So we just need this opposite value. Opposite value is y value. It's a square root 3 over 2. So that's why we have sine pi over 3 equals to root 3 over 2. Okay, those are important angles. So gradually we need to remember those. Okay, and down later on, right, we have this one. We have this chat. This chat we need to memorize. Going to calculus course, we need to memorize this chat. So sine pi over 3, well, pi over 3 is 60 degrees, right? Sometimes it's difficult to remember the radian form. You can convert into degree form. Sine 60 degrees, or pi over 3 equals root 3 over 2. Cosine pi over 3 equals adjacent over hypotenuse, or adjacent is x value, it's half. Half over 1 is half. And tangent of pi over 3 equals to opposite divided by adjacent, right? Opposite is y value, adjacent is x value. So root 3 over 2 divided by 1 over 2 equals to root 3. Cosecant of pi over 3 is 1 over sine pi over 3, which is a flip, right? When we flip, we get root 3 equal to 2 divided by root 3. When we flip, we get 2 divided by square root of 3. But then we need to rationalize the denominator because square root of 3, is considered in the denominator is considered as not simplified. Because we wouldn't say 2 apples shared by square root of 3 people, right? So we want to rationalize the denominator. How do we rationalize? We multiply by 1. And this one is root 3 over root 3. This process is called rationalize. In this case, we would get 2 root 3 divided by 3, because square root 3 times square root 3 is the square root of 3 squared, which is just 3. So that's how we get cosecant pi over 3 equals to 2 radical 3 over 3. Because first we flip sign, pi over 3, the 2 over square root of 3. Then we multiply by square root 3 over square root 3. So we get 2 radical 3 over 3. Secant pi over 3, secant is 1 over cosine. So we just flip half. So we get 2 over 1. 2 over 1 is 2. Cotangent pi over 3, which is flip tangent pi over 3. Tangent pi over 3 is square root 3, and we flip it, so we get a 1 over square root 3. So 1 over square root 3, or we can use the definition adjacent side over opposite side. All right. Adjacent side is x value. Opposite is y value. We could do half divided by root 3 over 2. All right, then we simplify, we get root 3 over 3. Or we can just flip over tangent pi over 3, we get 1 over root 3. Then again, we rationalize the denominator. We multiply by square root 3 over square root 3. Then we get square root 3 over 3. So we want the denominator to be a whole number, to be a counting number. Right? So the denominator we want it to be a counting number. 1, 2, 3, 4. This is called a counting number. All right. Any questions? Okay, let's see the second one. B. T equals pi over 2. It's very similar, right? T equals pi over 2. But this point falls on y-axis. So Jeremy showed us the 4 special points, right? This point is 1, 0. This point is 0, 1. And this point is -1, 0. This point is 0, -1. So those are 4 very special points on unit circle. Well, let's try to find the sine value. So I won't be able to draw the triangle, right? Because how do I draw the triangle? I can connect this point to 0, so I get this one. But then I won't be able to draw another line, the hypotenuse. The hypotenuse is the same as this, right? You see this hypotenuse falls with this y value. So we won't be able to draw the triangle, but we can use the definition to find the value of it. A flipping part again. So cosecant, the definition of a cosecant is 1 over sine. Let me write on this side. So the definition, let me write here. You see here cosecant. Oops. Interesting, it doesn't come to above. Why not? Okay. So this box is a definition. Okay, it's a definition of these trig functions. So what is the definition? So we know sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, right? Tangent, opposite over adjacent. So those 3 are basic definitions. And then how is this cosecant defined? Cosecant equals to 1 over sine. That's the definition. And secant equals to 1 over cosine. Tangent equals to 1 over cotangent. Well, let's say cotangent actually. Cotangent equals to 1 over tangent. So I'm just not writing the angle. All right, the angle have to be the same. If we use a t, so this would be cosecant t equals to 1 over sine t. And secant t will be 1 over cosine t. Cotangent t would be 1 over tangent t. That's the definition. That's how is it defined. So if we know sine of pi over 3 is √3 over 2, then cosecant pi over 3 is just flip, right? So 2, denominator of 2 becomes the numerator, and the numerator square root 3 becomes the denominator. So which is 2 over square root of 3. Just flip the numerator and denominator because it's an inverse, reciprocal. 1 over something, like a 2.5. 2.5 are reciprocal to each other. You just put a 1 over it. So that becomes 2 square root 3. Then we need to rationalize the denominator. We multiply by square root 3 over square root 3. So we changed the denominator to be 3, to be a whole number. Okay, Rinda, does that make sense? Does that answer your question?
But why are you multiplying both of them with square root of 3 over square root of 3?
Okay, because the square root of 3 is an irrational number. We don't talk about square root 3 of people, right?
Yeah.
We can talk about people like 1 person, 2 people, 3 people. We can talk about the square root of 3 apples shared by 2 people. This makes sense in math. Something shared by 2 people. But if we do 2 divided by square root 3, it seems like 2 apples shared by square root of 3 people. Square root of 3 people is not a whole number. Does it make sense?
Yeah, it makes sense.
It's an irrational number. So in mathematics, we don't want to divide it by a non-whole number. We want to divide it by a natural number, counting number, let's say, counting number. Counting number starts from 1, 1, 2, 3, 4, 5, so on and so forth. we call it simplified. You see here we have divided by 2, that's fine. Divided by 3, divided by 3, that's fine. We don't want to divide by an irrational number. Square root of 3 of people, how many people is the square root of 3 of people? We don't want to see it. You have to cut another person. Okay, anyway. So this process is called a rationalize. This process is called a rationalize. 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 So which means we want to make the denominator a whole number. Okay, great. So half for pi over 2 is similar, right? But the angle is a special angle. So let's follow the definition. So this point is 0, 1. So x value is 0, y value is 1. So sine pi over 2 equals to the opposite, right? So here, y divided by 1. What's just y? Well, what's y here? Y is 1. So sine pi over 2 is 1. A number we need to remember, an equation we need to remember. So sine 90 equals to 1. Cosine 90 equals 0. You see, we do not have that. Right? We cannot make a triangle out of this point. So those 4 points have some special sine, cosine, tangent values. So sine pi over 2 is 1. Cosine pi over 2 is 0. And then cosecant pi over 2 equals 1 over sine, which is 1 over 1. It's also 1. And the secant, we cannot do secant. Secant is not defined. Secant pi over 2, let's write here. So secant pi over 2 is undefined. Because of why? Because if we put a 1 over 0, we don't want to divide something by 0. So undefined. Secant pi over 2 is undefined. Then what's tangent? Tangent is opposite over 0. Tangent is also undefined. Right? Tangent pi over 2. Oh, let me write together. Tangent pi over 2 and the secant pi over 2 are undefined. Because we would have something divided by 0. We have 1 divided by 0. But in mathematics, we cannot divide by 0. However, cotangent is okay. Cotangent equals to adjacent over opposite. Opposite is 1, adjacent is 0. 0 divided by 1 is 0. So for pi over 2, this point, we have those 4 values. We have sine pi over 2 equals 1, cosine pi over 2 equals 0, cosecant pi over 2 equals 1, cotangent pi over 2 equals 0. Other 2 functions are undefined at this point. All right, now comes this very important table. This table, we need to, well, let's explain this table. Try to memorize it. So pi over 6 is a 30 degree, all right? Pi over 4 is 45 degree. Pi over 3 is 60 degree. Pi over 2 is 90 degree. Then actually we have pi. I'm going to add another line here, pi. Pi is 180 degree. Okay, those are some important values. As we calculated in the example, right? We calculated pi over 3. Pi over 3 and the pi over 6 are complementary angles. Pi over 3 plus pi over 6 equals to pi over 2. When 2 angles adds up to pi over 2 or 90 degree, we call them complementary angles. If they are complementary angles, we have those co-functions. We have a sine pi over 3 equals to cosine pi over 6. Now I have cosine pi over 3 equals to sine pi over 6. Okay, for complementary angles, sine of one equals to cosine of the other. Cosine of one equals to sine of the other. So here we can see 30 and 60 are complementary angles, right? So pi over 6 and pi over 3 are complementary angles. And 0 and the pi over 2 are complementary angles, right? Because 0 plus pi over 2 are complementary angles. But what about the pi over 4? Pi over 4 is complementary with itself, because pi over 4 plus pi over 4 equals to pi over 2. So that's why we see sine of pi over 4 equals to cosine pi over 4, because pi over 4 complementary to itself. That's why sine and cosine equal each other. Let's see 0 and pi over 2. 0 and pi over 2 are complementary angles. So sine of 0 equals to cosine of pi over 2. Cosine of 0 equals to sine of pi over 2. And pi over 6 and pi over 3 are complementary angles. So sine of pi over 6 equals to cosine pi over 3. Right? And cosine pi over 6 equals to sine pi over 3. Right? You see this? Right? You can make this. You see those two equal to each other. Those two equal to each other because they're complementary angles. Then once we know sine and cosine, we can derive tangent, cotangent, secant, cosecant. So by using the definition, by using the relationship, all right. So most importantly for us to remember those two lines, all right. But indeed, just one line. It's indeed just this. Remember the angle, right? Then remember the sine value. As long as we remember those two, it's so helpful for calculus courses. Remember sine pi over 6 or sine 30 degree equals to half. And sine pi over 4 or sine 45 degree equals root 2 over 2. Sine pi over 3 or sine 60 degree equals root 3 over 2. Sine pi over 2 equals to 1. Then what about sine pi? Sine pi is 0. And the cosine pi equals to -1. Right? Then we have a 3 pi over 2. So 3 over 2 pi. 3 over 2 pi. 3 over 2 pi, sine value equals to -1. Cosine value equals 0. Remember, those are four special points. Those special 4 points. Right? So that's why they have a 0, 1 for sine and cosine. 0, -1, -1, 0 for sine and cosine. All right, so try to memorize this table. So today, I think you have a lot to do. Right? Try to memorize the definition of sine and cosine. Try to understand the complementary angles, which means two angles adds up to 90 degrees. And try to remember the first two columns. All right, these first two columns. Remember some special angles. Those special angles: 0, pi over 6, pi over 4, pi over 3, pi over 2, pi, 3 pi over 2. and try to remember their sign values. All right. And draw the unit circle. Draw the triangles to convince yourself. Especially for pi over 4. Pi over 4, the point will be here, right? Then if we draw a line, we say this is the line y equals to x. X value equals to y value. Let's see some exercise. Okay, so we have this thing. So this thing helps us to understand a sine value or cosine value can be negative, can be positive. Remember, I have 4 triangles. Let me draw 4 triangles here. So with the point in the first quadrant, we see this triangle, right? In the second quadrant, we see this triangle. Okay, I want to leave those words. See, in the first quadrant, I wrote all. Oh, let me actually pull this further. All sine. I'll explain what does that mean. All sine, tangent, cosine. Actually, let me make this longer. Okay, I'm trying to make 4 triangles, right? Triangles in the first quadrant, in the second quadrant, in the third quadrant, and in the fourth quadrant. So working these 4 triangles. All right, let's figure out these 4 points. Just use positive value and negative value, all right? First quadrant, of course, x value is positive, y value is positive. Let's figure out second quadrant. Second quadrant, oops. We're looking at this point, all right? So second quadrant, x value is negative, and the y value is positive. Let's think about third quadrant. Both be negative, right? X value is negative, y value is negative. And fourth quadrant, x value positive, y value negative. So think about the t here. T in the first quadrant, of course, sine, cosine, tangent, every 6 trig functions all positive. That's what this all means. This all means these 6 functions: sine, cosine, tangent, cosecant, secant, cotangent. All 6 values being positive. Because x is positive, y is positive, right? Because opposite is positive, adjacent is positive. Just make sure we have 4 triangles. Okay, those are 4 triangles. Four triangles. So x positive, y positive. So sine, cosine, all 6 trig functions are positive. But let's see the second quadrant. Second quadrant, x value is negative. So that's why only sine is positive. Why? Because sine equals to opposite over hypotenuse. Opposite is y value being positive. But cosine is adjacent over hypotenuse. Hypotenuse is always positive, but adjacent x value is negative. So cosine is negative. Then tangent equals sine over cosine equals positive divided by negative. So tangent is negative, right? So sine and the cosecant. Sine and its inverse cosecant are being positive. Right? Sine and its inverse cosecant being positive. Well, let's think about tangent. Tangent of the angle equals opposite over adjacent. Well, negative divided by negative. Well, that's still positive. But think about the sine. Sine is opposite, which is a negative value, divided by hypotenuse, which is a positive value. So sine is negative. Cosine is adjacent over hypotenuse. Adjacent is x value, which is negative, divided by hypotenuse, which is a positive value. So cosine is negative. But tangent is positive. Because tangent equals opposite over adjacent, negative divided by negative stays positive. So tangent is positive. Similarly, cosine is positive in the first quadrant. All others are negative. Well, of course, it's with its inverse, all right, cotangent. So tangent and cotangent are positive. Then fourth quadrant, cosine and secant are positive. So how do we try to remember this? That's one thing. All students take calculus. So the people use this to try to remember this. So all means everybody. Sign S, start with S. All students, right? The students use this S to represent the sine and its inverse cosecant. Take T is this tangent and the cotangent. Calculus use this C to represent the cosine and secant. So all students take calculus to remind us sine is positive in the second quadrant, tangent and the cotangent positive in the third quadrant, cosine and secant positive in the fourth quadrant. All right, any questions? Okay, so that's here, right? That's all here. That's this table. So use a picture to, to convince yourself, and use this, phrase, all students take calculus, to help you remember the value being positive or negative. Let's see an example. So example A, cosine 2 pi over 3. Right? 2 pi over 3 is bigger than pi over 2, but smaller than pi. So it's in the second quadrant. Or cosine in the second quadrant is negative. It's in negative. But what about its value? Its value, we just look at its reference angle, right? So this is a reference angle, right? We'll only look at those reference angles. So we do pi minus 2 pi over 3. Or pi minus 2 pi over 3, which is pi over 3. So we have cosine 2 pi over 3 equals to negative cosine of its reference angle. Okay, its reference angle, because it's in the second quadrant. So second quadrant, right? Because in the second quadrant, we use the formula pi minus the angle, right? So pi minus, in this case, 2 pi over 3, which is pi over 3. Because 1 pi, we change to be 3 pi over 3. So 3 minus 2, that's 1. So 1 pi, so 1 pi over 3. That's a formula for second quadrant, right? So cosine 2 pi over 3 equals to negative value, because it happens in the second quadrant, cosine being negative. Cosine of its reference angle, which is, we know cosine pi over 3, right from the table. We need to remember, gradually to remember. Cosine pi over 3 is half, equals sine pi over 6. So get a cosine 2 pi over 3 equals negative half. Equals negative half. Or second one, tangent of negative pi over 3. Now this angle measured be negative. So that means this angle in the fourth quadrant. In the fourth quadrant, tangent is negative, right? Tangent is negative. So we need, so fourth quadrant, so negative pi over 3 is in the fourth quadrant. So fourth quadrant. Fourth quadrant, negative pi over 3 equals to that's negative. So this one, just do pi over 3, okay? Because in the fourth quadrant you see here, because it's a negative measure. So if it's a negative measure, it happens in the fourth quadrant, and its reference angle just the positive, just positive of the angle, right? So we look at this triangle. Look at this triangle, and this is this here is its reference angle, right? You see negative pi over 3, right? It's a reference angle. We just connect those 2 points. We drop a line to here. So this angle, the positive value, is exactly the reference angle. So it's reference angle just pi over 3 in the first quadrant. So tangent of negative pi over 3 equals to negative, because tangent in the first quadrant be negative. Only cosine and secant positive. All others are negative. So get negative tangent of its reference angle. Its reference angle is positive pi over 3. And tangent pi over 3, we go to the chat, equals the square root 3. So tangent pi over 3 is root 3. And negative tangent pi over 3 equals to negative pi over negative square root 3. Well, C, sine of 19 pi over 4. How can we figure out 19 pi over 4? Which quadrant it is? Well, let's do this. So 19 pi over 4. Think about, okay, 16. So 19, we're going to break up into 16 plus 3, because we know 16 can be divided by 4, right? 16 divided by 4, that's 4. So we get a 4 pi plus 3 over 4 pi. Then 4 pi just running around 2 circles. So we can ignore this. Ignore this. So we take this reference number 3 over 4 pi. Then 3 over 4 pi is in second quadrant. 3 over 4 pi in second quadrant. And we want to find the sine value. Second quadrant of sine is positive. But what is its reference angle? Its reference angle is pi minus 3 over 4 pi, which is 1 over 4 pi. Right? So that means this equals the sine of pi over 4, which is root 2 over 2. So sine of 19 pi over 4 equals to sine of 4 pi plus 3 pi over 4. 4 pi, we're running around 2 circles, right? So you can ignore that. Then 3 pi over 4 is in the second quadrant. Second quadrant sine value being positive. So that equals a positive sine of its reference angle, right? Its reference angle. Reference angle is pi over 4, which is, we go back to the chat, with root 2 over 2. Square root 2 over 2. Okay, anybody has any questions?
Yeah.
Yeah.
Where did 3 pi over 4 come from?
Oh, from here. So 19 pi over 4, right, can be split into 16 plus 3 pi over 4. Does this make sense?
Yeah.
Okay, so then I can split it into 16 pi over 4 plus 3 pi over 4. What's 16 pi over 4? That's 4 pi, right?
Yeah.
Okay. So 4 pi, remember what is 4 pi? We talk about the reference angle, right? Let's say we start from here, start from this point. We run 1, 2 pi, 4 pi, right? 4 pi running 2 circles. What we're taking is the smallest one. We're taking this smallest number. So 3 over 4 pi. So 19 pi over 4 is, we can use 3 over 4 pi to speak for it. So this is representative. Because 4 pi was just running around 2 circles. The coterminal is the same. So any number, if we can find out 2 pi in it, 4 pi in it, 6 pi, 8 pi, 10 pi, those even pi's, we can ignore them. We use the smallest positive number between 0 and 2 pi. Does this make sense?
Not really, but it's okay.
Okay, let's go back a little bit. Okay, we're talking about points on 4 quadrants, right? Let's think about this point. So I'm going from here to here. Let's say this is 3 pi over 4. Okay, I'm just using this one as example. 3 pi over 4. So that's this point, right? That's this angle I'm measuring. But now I do not stop here. I keep going. I'm going 1 round up here. I still stop here. I go another round, stop here. Do you see I end up at the same point?
Yeah.
Okay, the same point, right? So that's why it's still the same point. If it's still the same point, instead of talking about 3 pi, let me make another one. I could have a 3 pi over 4 plus 2n pi, 2k pi. K is just a counting number. K can be 1, 2, 3, 4, so on and so forth. 1, 2, 3, 4, so on and so forth. All right. We can imagine this 2k pi as 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, all those n pi's. Because 2 pi, those even pi's. Because even pi's means we're running around a circle. So here, 19 pi over 4. 19 pi over 4 can be simplified as 4 pi plus 3 pi over 4. That means, so 3 pi over 4 is here. That means I just run around 2 more circles, but I end up at the same point. I end up at the same point. So instead of talking about 4 pi, 19 pi over 4, I'm going to talk about 3 pi over 4 because that's exactly the same point. So I simplify this 19 pi over 4 to be 3 pi over 4 because it's talking about the same point. Does that make sense?
Yeah, it makes sense. But earlier you said we can ignore the 4 pi. Like, why are you ignoring the 4 pi?
Because the same point. Because this is the same point. Because at this moment we're talking about the same point. I can still keep running. I can run another 2 pi. I have 6 pi plus 3 pi over 4. I can keep running, but I'm still talking about this same point.
Okay.
Okay. So we just ignore even pies. If we can reduce the angle with the even pies, we just ignore the even pies, because even pi means we're running around circles. We end up at the same, because 2 pi is one circle. Okay. Let me actually delete this. Okay, anybody else have any questions? Trigonometry function is not easy because it has a lot of stuff. It involves a lot of stuff. But let's just do little by little, all right? Okay, so we know the definitions of sine, cosine, tangent. And indeed, as long as we know sine, we know the rest of it. And this table is important to remember. Those special angles, you know, in calculus class, we always use those special angles. And at least to remember the sine value. So we use this, all students take calculus to remember this value of sine, cosine, you know, comes from those rectangle, triangles, right? So sine of 19 pi over 4, we simplify to be sine of 4 pi plus 3 pi over 4. You know, sine, just 4 pi, just ignore it. So we have sine 3 pi over 4. But remember, we only ignore even pies. We can ignore 2 pi, 4 pi, 6 pi. But for odd pies, we may not be able to ignore, all right? We ignore even pi. So sine 3 pi over 4, 3 pi over 4 is in the second quadrant sine value being positive, so we have plus sign. And the sine of its reference angle in the triangle, right, which is pi over 4. And sine pi over 4, we know is root 2 over 2. Okay, I'm going to stop here. I think this is a lot. Yeah, we're not going to talk about this. We're not going to talk about use calculator to find a value. For us, we don't want to estimate. So I'm going to leave this next class, even odd properties, all right? So let me assign you some homework. Yeah, we still have about 15 minutes. Let's just try a couple of them. Let's actually talk about the 1 and 2. Let's see. So let's all try. Hopefully some of you can show. So one thing, let a point be the terminal point on the unit circle determined by t. Then sine t equals to cosine t equals to and tangent t equals to. This means determined by the angle. And the 2, if a point is on the unit circle, then x squared plus y squared equals what? So for all t, we have sine squared plus cosine squared equals to, okay, this is a very important identity we haven't talked about yet. Let me just add to the homework. So homework 15, I assigned you so homework 15 for 5.1, 35 to 38, 5.2. Okay, actually it's here. One of the questions, but you may try yourself. Okay, for 1 and 2. 1, 2. I'm adding up this to homework 15. 1 up to 1 and 2. Okay, good practice. 5, 6, 7, 8, 9, 10. Okay, 5 to 10. 1, 2, and 5 up to 10. 1, 2, 5 up to 10. All right, anyone has any questions? Should we try a couple? Let's try 11 and 12. All right, let's all try 11 and 12. Hopefully someone can show us. Not try B. Oh, let's do this. Let's not try B or C. All right, for now. But for homework, you need to do A, B, C. For now, let's just try 11 up to 14, 8. Let's try those 4 questions. Hopefully someone can show us, because this only involves the sine and cosine. So sine we know being positive in the first quadrant and second quadrant. Cosine is being positive in the first quadrant and the fourth quadrant, right? So let's try to figure out 11 to 14 only for 8. Okay, anyone like to show? Or maybe we try together. Let's see the first one. Sine 7 pi over 3, right? 7 pi over 3 is in the second. 7 pi over 3, we don't know in which quadrant, right? Normally, when we look at that number, it's kind of confusing. So let's try to figure out which quadrant this one is. We know 7 can be split into 6 plus 1. Because why we want to do that? Because it's divided by 3, right? We know 6 can be divided by 3. So first, we split 7 into 6 plus 1. Then 6 divided by 3, we know that's 2. So we get 2 pi plus pi over 3, right? So 6 pi divided by 3, that's 2 pi. 1 pi divided by 3, just pi divided by 3. So now we get an even pi. So we get an even pi, just ignore it. So we can ignore this 2 pi. So the terminal is the same for 7 pi over 3 and pi over 3, or the terminal point. The terminal point for 7 pi over 3 is the same as pi over 3. So that means sine 7 pi over 3 equals to sine pi over 3. If we have trouble to remember, sine pi over 3 is sine 60. It's the square root of 3 over 2. So gradually, we need to remember the value of in the table, the value of sine for some special angles. So that's the first one. Let's see the second one. Second one, we'll get a cosine negative pi over 3. Right? Negative pi over 3 in the fourth quadrant. So we know that equals to cosine, and cosine value in the first quadrant is positive. So that equals to positive of cosine pi over 3. What is cosine pi over 3? That's a sine. Cosine pi over 3 equals to sine. Cosine pi over 3 equals to cosine 60, right? Cosine 60 equals to sine 30, which is a half. So negative pi over 3 is in the fourth quadrant. In the fourth quadrant, cosine being positive. And the triangle we look at, the reference angle is pi over 3. So cosine negative pi over 3 equals to positive cosine pi over 3 equals to half. Now let's look at 13. 13, negative pi over 2 is negative, right, in the fourth quadrant. And sine is being negative in the fourth quadrant. We get a negative sine of pi over 2. But what's sine pi over 2? Sine pi over 2 have a very special value, 1. So that equals to negative 1. Well, now let's look at about 14. 14, let's think about this angle, right? This is negative 3 pi over 2. If we draw the picture, that this is, negative pi over 2, negative pi 3 over 2. So this was starting from this, right? So running up to this y-axis, that's negative 3 pi over 2. But negative 3 pi over 2, we could also see that's positive pi over 2, if we can see that. Right? If we measure from this side, because the terminal point is the same as positive of pi over 2. So this equals to positive sine pi over 2. And we know sine pi over 2 equals 1. Okay, so for doing your homework, try to draw the pictures. All right, try to draw the terminal point. Try to draw the terminal point, then think about the reference number or reference angle. Then use this table. Use this table of special values. Use this table of special values, special angles, values of special angles. Okay, anybody has any question? Yeah, trigonometry involves a lot, but once you get used to it, it's not difficult. It just seems like overwhelming at the beginning. All right, if no question, I'll see you next week. All right, have a good weekend. Okay, bye. Have a good weekend.